Good morning, y'all. It is Friday, April the 11th, and I am going to get right into it this morning because there is genuinely no time to waste on this one. I have been sitting here since about 5 o'clock going through the model data, going through the upper air analysis, going through the surface observations, and what I am seeing is the kind of setup that makes every part of my meteorology brain stand at full attention, because the severe weather that is about to develop across this country over the next 48 to 72 hours is not a gradual buildup. It is not a slow moving threat that gives you days and days to casually think about preparation. It is an explosion, a rapid, violent, multi-hazard, severe weather explosion across a corridor that stretches from the southern plains all the way through the mid-south and into the Tennessee Valley. And the word explode, I want y'all to understand, I am not using that word for drama. I am using it because it is the most meteorologically accurate description of what the atmosphere is about to do. When forecasters talk about convective initiation and the moment when thunderstorms first fire in an unstable environment, there are setups where storms develop gradually, and there are setups where they absolutely explode into existence all at once across a wide area, producing dangerous weather almost immediately and with very little lead time between initiation and impact. This is one of those setups, and I need every single person in the affected areas to be ready before the atmosphere pulls the trigger, not scrambling to get ready after it already has. Let me explain to y'all why this particular setup is so explosive, because I think the science here is genuinely important and understanding it is going to help you take the right actions over the next several hours. The key ingredient driving the rapid and violent nature of what is developing is something meteorologists call a capping inversion. And I want to explain what that is in plain terms because it is honestly one of the most important concepts in severe weather forecasting and one of the least understood by the general public. A capping inversion is essentially a layer of warm air sitting in the middle of the atmosphere, typically between about 3,000 and 8,000 feet up. That acts like a lid on a pressure cooker. Underneath that cap, the atmosphere near the surface is building up enormous amounts of heat and moisture throughout the day. The instability, the fuel for thunderstorms, is accumulating and accumulating and accumulating, but the cap is preventing it from releasing. So instead of getting scattered light thunderstorms developing gradually through the afternoon, you get nothing, nothing, nothing. And then when the cap finally breaks, either because the surface has heated enough to punch through it or because a strong forcing mechanism like a front or a jet streak removes it, every bit of that accumulated instability releases at once, all of it simultaneously across a broad area, and they do not get to their shelter, and they do not survive a storm that they absolutely would have survived if they had just been awake and moving towards safety. Y'all, I created Y'all Call specifically because of this problem, specifically because I could not stand the idea of warnings being issued and people not receiving them in time. When a tornado warning polygon covers your exact location on the map, I call your phone, me, a direct phone call to your number that rings and rings until you answer it and wake up, not a push notification that gets suppressed, not an alert tone that your sleep mode kills, a phone call, the kind that wakes you up at 2 in the morning when nothing else will. Y'all Call is $14.95 for a full year of protection, and the link is right there in the description below this video. I am asking you right now, before you finish watching this forecast, before you go about your day, please set it up. The overnight window for this outbreak is less than 12 hours away, and I want every single one of y'all in the affected corridor protected before it opens. Now, let me talk about the hail threat from this setup, because it is going to be significant and it is going to catch a lot of people off guard. When you have CAPE values in the 3,000 to 4,000 joule range combined with very cold temperatures at the tops of the thunderstorm anvils, And the anvil temperatures we are looking at today are exceptionally cold, running at -60 to -70 degrees Celsius at the storm tops. The environment for large hail growth is about as favorable as it gets. Hailstones grow by cycling up and down within the updraft of a thunderstorm, accumulating layers of ice with each cycle, and the stronger the updraft and the colder the upper levels of the storm, the larger the hail can grow before it finally falls out. In the strongest supercells today, I think golf ball sized hail, that is about 1 3/4 inches in diameter, is likely across a broad area, and in the most intense cores, baseball-sized hail, 2 3/4 inches, is a genuine possibility across portions of central Oklahoma and south central Kansas. I want y'all to understand what baseball-sized hail means practically. It means vehicles get destroyed, windshields shatter, sheet metal gets dented and punctured, roofs on homes and businesses sustain damage that requires complete replacement, and anyone caught outside when that hail is falling is in a genuinely life-threatening situation, because hail of that size falls at terminal velocities approaching 60 to 80 miles per hour. If you hear a tornado warning or a severe thunderstorm warning this afternoon, please get inside immediately. A hail warning is not a stay on the porch and watch warning. It is a get inside and stay away from windows warning. The flooding threat from this system deserves its own dedicated discussion because it is going to affect a much broader geographic area than most people are currently accounting for. The moisture streaming northward ahead of this system is exceptional. I mentioned the precipitable water values running 30 to 40% above normal. And when those moisture values interact with the training thunderstorm pattern that is going to develop behind the initial line of supercells, the rainfall rates in some areas are going to be extraordinary. Training thunderstorms are storms that keep moving over the same location over and over again, like train cars passing the same point on a track, and they are one of the most efficient mechanisms in the atmosphere for producing catastrophic local rainfall totals in a short period of time. The areas I'm most concerned about for that training thunderstorm and flash flood scenario are the Ouachita Mountains of western Arkansas and eastern Oklahoma, the Ozark Plateau of northern Arkansas and southern Missouri, and portions of the Tennessee Valley in northern Alabama and southern Tennessee. In the most extreme training scenarios,